I am Kale, RBNB College, Rampur. We see here 12 Science Mathematics Part 2, lecture number 11, and topic is indefinite integration. In indefinite integration, we see here exercise 3.2a. In that we have completed question number first and question number second is going on. In question number second, we have completed problem first to 9. Today here we will see the problems from 10 and onwards. So question is integrate the following functions with respect to x, and here 10th problem is cos 8 raised to x into quat x. This is the 10th problem. Now call this as I. So let I is equal to integration of cos raised to 8x into quat x dx. Now here we may consider cot x as a cos x upon sin x. Cot x as a cos x upon sin x. So we write this as integration of cos to the power 8x and cot x as cos x upon sin x dx. Now here if we put sin x is equal to t, then we get cos x dx as a dt. But here cos raised to 8x, we have to convert this cos x in terms of sin x because we put sin x as a t. So we write here this is equal to integration of cos raised to 4x into cos raised to 4x and cos x upon sin x dx. And now this cos raised to 4x we write it as I is equal to integration of cos square x to the square. This 4 as 2 to the power 2. Again here also cos square x as cos square x and to the power 2. This cos raised to 4x also we write cos square x to the power 2. And here cos x upon sin x dx. And now here we put cos square x as a 1 minus sin square x. Here also and here also. So this is equal to integration of cos square x, that is 1 minus sin square x to the square. Here also cos square x as 1 minus sin square x to the square and into cos x upon sin x dx. And now put here sin x is equal to t. Now use here substitution method. Put sin x is equal to t. Now differentiate with respect to x on both sides. Derivative of sin x, d by dx of sin x is equal to d by dx of t. So derivative of sin x is cos x, and here derivative of t is dt upon dx. Carry that dx to left side, and therefore we get here cos x dx is equal to dt. So this is equal to required integral I becomes I is equal to integration of 1 minus, now here put sin x as a t, so t square and bracket square, t square bracket square. Here also 1 minus t square bracket square. This cos x dx is replaced by dt, so dt and upon cos x dx is dt, and this 1 upon sin x as we write this as 1 upon t into cos x dx as a dt. Now here take the product of, take here firstly expand these brackets. We expand these two brackets and then we take the product of these two brackets. So here we use the formula a minus b bracket square. What is that formula? A minus b bracket square is equal to a minus b bracket square. It is equal to a square minus twice ab plus b square. This formula we have to use or expanding this. So I is equal to integration of 1 minus t square. So a square, that is 1 square, minus twice into a into b, that is twice into 1 into t square, twice t square, and plus b square, so plus t square to the square, that is t to the power 4. And now again write this bracket, because same bracket, so it is again 1 minus twice t square plus t to the power 4, and this divided by 1 upon t means divide this as a t into dt. Now we have to take the product of these two. So it is equal to integration of 1 into this bracket, 1 into 1, 1 into minus twice is t square plus 1 into t to the power 4. So write this bracket as it is while we multiply by 1. That is 1 minus twice t square plus t to the power 4. Now multiply by minus twice t square to this same bracket. That is minus twice t square into 1. It is minus twice t square. Now here minus and minus become plus. 2 to the 4. T square into t square, t to the power 4. Now multiply by this minus twice t square to t to the power 4. It is minus 2 and t square into t to the power 4, that is t to the power 2 plus 4. Using the rule of indices, we take the additions of powers, that is 2 plus 4, it is 6. Now here multiply by t to the power 4 to this bracket. So t to the power 4 into 1, so plus t to the power 4. Then again t to the power 4 into twice t square, firstly plus into minus, it is minus 2 into t to the power 4 plus 2, that is 6. Then t to the power 4 into t to the power 4. Before that plus into plus, that is plus. And t to the power 4 plus 4, that is 8, and whole divided by t, and here write dt. And now here take the separate division for each term. Firstly collect the same powers, the terms of same powers, and so we get here integration of, here constant term 1 as it is. Now here minus twice t square, here minus twice t square. So these are the two terms of t square. So minus 2 and minus 2, it is minus 4 t square. Now here this t to the power 4, this 4 t to the power 4, and again here t to the power 4. There are three terms of t to the power 4. T to the power 4 plus 4 t to the power 4 plus t to the power 4. So it is plus 6 t to the power 4. 1 plus 4 plus 1, that is 6 t to the power 4. Now here collect the terms of t to the power 6. Here minus 2 to the 2 into t to the power 6 and minus 2 into t to the power 6. Minus 2 minus 2, that is minus 4 t to the power 6. Get it? Now here collect the term of t to the power 8, and there is, I think, single term here, plus t to the power 8. T to the power 8 and divided by t dt. So here 1 as it is, minus twice t square minus twice t square minus 4 t square, then t to the power 4, here 1 plus 4 5 plus 1 6, and then t to the power 6, here minus 2 t to the power 6 minus 2 t to the power 6, that is minus 4 t to the power 6 plus t to the power 8 divided by t. Now here take the separate division. So this is equal to, we divide every term of numerator by t separately and then take separate integration also. So it is equal to integration of 1 upon t dt minus integration of 4t square upon this t dt plus integration of 6t to the power 4 upon t dt minus integration of 4t to the power 6 upon t dt and plus integration of t to the power 8 upon t dt. So we separate numerator and also we take here separate integration. 1 upon t minus 4t square upon t plus 6t to the power 4 upon t minus 4t to the power 6 upon t plus t to the power 8 upon t. So this is equal to integration of 1 upon t. here it is integration of 1 upon t dt minus integration of here t square upon t, 1 t get cancelled. So we get here this minus 4 constant, take outside the integral, minus 4 into integration of here t dt, t and t get cancelled, this 4 outside the integral. Now here this plus 6 constant, take outside the integral, and integration of t to the power 4 upon t, 1 t get cancelled, so we get here integration of t to the power 3 dt. Now here minus sign as it is, this constant 4 take outside the integral, 4 into integration of t to the power 6 upon t, that is t to the power 5, 1 t get cancelled, so t to the power 5 dt plus, now here t to the power 8 upon t, 1 t get cancelled, so it is equal to integration of t to the power 7 dt, here dt. Now take here integration using the formula, which formula? Integration of x to the power n dx, integration of x to the power n dx, that is equal to x to the power n plus 1 upon n plus 1 plus constant of integration. This is the important formula. We use this formula to find the integration of all these terms. Now here first integral is integration of 1 upon t. Now 1 upon t is the derivative of log t. Derivative of log t is 1 upon t. Therefore integration of 1 upon t is log of t. Minus 4 as it is. Here t to the power 1, t to the power is 1. So t to the power 1 plus 1, that is 2, divided by here 2, plus 6 into t to the power 3 plus 1, that is 4 upon 4. Minus 4 as it is, t to the power here 5 plus 1, 6 upon 6, plus t to the power 7 plus 1, 8 upon 8, plus constant of integration. And lastly put the value of t as t is here sin x, t is here sin x, and therefore last step I is equal to required integral log of t, t is sin x, t is sin x, minus here 2 to the 4, so 2, and t square, that is sin square x, plus 2 3 the 6 divided by 2 to the 4, so 3 upon 2 is the constant, and sin x to the power 4 we write it as sin raised to 4 x, here minus 2 to the 4 divided by 2 3 the 6, and sin to the power 6x plus 1 upon 8, here the t is sin x, so sin raised to 8x plus constant of integration. This is the final solution for this problem. So here take the screenshot and write down in your notebook. Now see here answer. This answer does not match the answer given in the book. The answer given in the book is different, and this answer is different. So how to get the answer in the book? Now we solve this problem by another way and we can get the answer which is in the book. So here we solve this problem by second way. So here this is one method. Another method is here new book, new answer. So see here how to solve this. So this is equal to integration of cos raised to 8x as it is. This cot x we write cos x upon sin x. Cot x as cos x upon sin x. And here also we multiply by sin x upon sin x into dx. Get it? So we get here integration of cos raised to 8x into cos x, that is cos raised to 9x. Cos raised to 9x into this sin x as it is sin x dx, this sin x dx, and upon here sin x into sin x, that is sin square x, sin square x. So we get here, now here we put cos x is equal to t, cos x is equal to t, and then we get sin x dx as a minus dt. So here we express sin x in terms of cos x. So we put here sin square x is equal to 1 minus cos square x using the first fundamental identity. So it is equal to integration of cos raised to 9x divided by this sin square x as 1 minus cos square x and sin x dx as it is. And now we use here substitution method. We put here cos x is equal to t. We put cos x is equal to t. Derivative of cos x, we differentiate this equation with respect to x. So derivative of cos x is minus sin x. Minus sin x is equal to derivative of t is dt upon dx. So here it is sin x dx is equal to dt, but here minus sin x, so we carry that minus sign on the right hand side. So integrate here we substitute cos x is equal to t. We take the derivative with respect to x. Derivative of cos x is here minus sin x dx is equal to dt. Then carry this minus sign to the right hand side, and therefore we get here sin x dx is equal to minus dt. Now required integral I becomes I is equal to integration of, here we put cos x as a t, so it is t to the power 9 and divided by 1 minus cos x as a t, so it is t square, and sin x dx is minus dt. Now take this minus sign outside the integral, so we get here, we have here minus integration of t to the power 9 upon 1 minus t square dt. Again we multiply this minus sign to the terms in the denominator. So we get here t to the power 9 integration of t to the power 9 divided by minus 1 and minus plus t square. So plus t square we write firstly, that is t square minus 1 dt. In this way we get I is equal to integration of t to the power 9 upon t square minus 1 and here dt. Now here we divide numerator by denominator by using our previous methods which we learned in the school. So how we divide numerator by denominator? So it is equal to we have to divide t to the power 9. So here we take t to the power 9 and divide by t square minus 1. So here we take t to the power 7, so that t to the power 7 into t square we get t to the power 9. So t to the power 7 into t square, that is t to the power 9. And now here t to the power 7 into minus 1, that is minus t to the power 7. Here this become minus and this as a plus, and therefore we get here t to the power 7. Now here again we have to cancel this t to the power 7, or we have to divide this t to the power 7. So here we take plus t to the power 5, so that t to the power 5 into t square, that is t to the power 7 and plus minus t to the power 5 into 1, that is t to the power 5. Again change the sign, this become minus and this as a plus. This t to the power 7 and minus t to the power 7 get cancelled. So here we get t to the power 5. Again we divide by this t to the power, we have to divide this t to the power 5. So here we take t to the power 3, suppose t to the power 3, so that t to the power 3 into t square, that is t to the power 5. So we write here t to the power 5 and t to the power 3 into minus 1, that is equal to minus t to the power 3. Again here this minus sign and this plus sign, this t to the power 5 and t to the power 5 get cancelled to each other, and so here we get t to the power 3. Again we divide this t to the power 3 by this t square minus 1, and so we multiply here by plus t. So plus t into t square, that is t to the power 3 and plus t into minus 1, that is minus t, and now here change the sign, here minus and here become plus. So this t to the power 3 and t to the power 3 get cancelled to each other, and therefore we get here plus t, that is t. So here remainder is t. Now we write this fraction or this division. We write this required integral I is equal to here integration of quotient is t to the power 7 plus t to the power 5 plus t to the power 3 plus t, and plus here remainder is t, and divided by this t square minus 1, and then take this integration. We write this t to the power 9 upon t square minus 1. Here n upon d is equal to q is this question, plus remainder this t, and divided by this divisor, that is denominator. And so here question is this t to the power 7 plus t to the power 5 plus t to the power 3 plus t, and plus remainder here t, and divided by this divisor, that is t square minus 1. And so we now take here separate integration. And therefore it is equal to integration of t to the power 7 dt plus integration of t to the power 5 dt plus integration of t to the power 7, here t to the power 5, and then t to the power 3 dt plus integration of t dt plus integration of t upon t square minus 1 plus integration of t upon t square minus 1 dt. Now here these are the simple integrations using the power function, that is here integration of x to the power n dx, that is equal to x to the power n plus 1 upon n plus 1 plus constant of integration. We use this formula to solve this and this integration. Now to solve the last integration, we have to use here corollary. Which is the corollary? Integration of here suppose function and its derivative in the numerator with respect to x, so it is equal to log of function. This is the corollary. We have to use this corollary here. Means if we consider this is the function, then its derivative should be in the numerator. Then we use that corollary. So see here t square minus 1 and derivative of t square minus 1, derivative of t square minus 1, that is equal to twice t, because derivative of 1 is 0. So twice t is the derivative. Out of that t is present here. So we have to adjust only 2. So how we adjust this 2? We take here 2 and we cancel this 2 as like this, 1/2 into twice t. So 2 and 2 get cancelled. We have the original step. So now here take integration. So we get t to the power 7 plus 1, that is 8 upon 8 using this formula, plus t to the power 5 plus 1, 6 upon 6, plus t to the power 3 plus 1, 4 upon 4, plus t to the power, here it is 1 plus 1, that is 2 upon 2, plus 1/2, and here use the corollary, that is integration of f dash of x upon f of x dx, that is equal to log of f of x. So log of f of x, which is in the denominator, that is t square minus 1 plus constant of integration. Now resubstitute the value of t. What is t here? T is cos x. We put here t as a cos x, and so we get here cos raised to 8x divided by 8 plus cos raised to 6x divided by 6 plus cos raised to 4x divided by 4 plus cos square x divided by 2 plus 1/2 into log of cos square x minus 1 plus constant of integration. This is the final solution which is given in the book. The final solution, this answer is given in the book. Now here only we have seen here 10th problem we solve here 10th problem by two ways. Now here see 11th problem. 11th problem here, tan raised to 5x. Tan raised to 5x. So consider this as I. So I is equal to integration sin tan raised to 5x dx. We write the given problem like this. I is equal to integration of tan raised to 5x dx. So this is equal to integration of, we write this tan raised to 5x, we split this power using the rule of indices, that is tan raised to 3x into tan raised to 2x dx, that is 3 plus 2 is equal to 5. Now here we write this tan square x. We know that second fundamental identity is 1 plus tan square theta is equal to sec square theta. This is the second fundamental identity. And from this tan square theta, carry this 1, we get here tan square theta is equal to sec square theta minus 1. And therefore this is equal to integration of tan cube x into, we replace this tan square x by sec square x minus 1. Sec square x minus 1 dx. And now here multiply by tan cube x inside the bracket. So we get here integration of tan cube x into sec square x minus here tan cube x dx. We multiply by tan cube x to sec square x and 1 and we get this. Now here it is tan cube x. Again we put here tan cube x, or we write here tan x as tan cube x as tan x into tan square x. We split this power 3 as 1 plus 2. So integration of tan cube x into sec square x, and again write this tan cube x as minus tan x into tan square x dx. So this is equal to integration of tan cube x sec square x as it is minus here tan x. Now here again replace tan square x using second fundamental identity, it is sec square x minus 1. Here sec square x minus 1, tan square x as sec square x minus 1. So we write here sec square x minus 1 and take here square bracket dx. And so this is equal to integration of, now here multiply by tan x inside the bracket, and therefore we get tan cube x sec square x minus tan x into sec square x tan x sec square x, and this minus and minus become plus tan x dx. Now from these two terms we take here sec square x common, so it is equal to integration of tan cube x minus tan x into sec square x and plus this tan x dx. And now we separate the integration. We separate here integration. So this is equal to integration of tan cube x minus tan x into sec square x dx plus integration of tan x dx. And now observe here, we use here substitution method for this first integral. We call this as I1 plus I2. Left side is here I. So required integral I is I1 plus I2, where I1 is the first integral and I2 is the second integral. In I1 we put tan x is equal to t. In I1 put tan x is equal to t and differentiate this equation with respect to x, means dy dx of tan x is equal to dy dx of t. What is derivative of tan x? Sec square x. sec square x. On the right hand side, dt upon dx, carry that dx. So we get here sec square x dx is equal to dt. And therefore this required integral I becomes I is equal to integration of, now here put tan x as a t, so it is t cube minus, again here tan x as a t, and sec square x dx we replace by dt, and plus here the second integral as it is, that is integration of tan x dx. And so this is equal to, now take here integration of this bracket using this formula, integration of x to the power n dx is equal to x to the power n plus 1 upon n plus 1 plus constant of integration. So here it is t to the power 3 plus 1, that is 4 upon 4, minus here t to the power is 1, so t to the power 1 plus 1, 2 upon 2, and plus here we know that what is the integration of tan x. We have seen, we have proved here integration of tan x, integration of cot x, integration of sec x, and integration of cosec x. So we have integration of tan x as log of sec x, log of sec x, and now write here plus c as a constant of integration. So here put the value of t is here tan x, and so I is equal to, final solution, I is equal to tan to the power 4x upon 4 minus tan square x upon 2 plus log of sec x plus constant of integration. This is the final solution for this problem number 11. Now here take the screenshot and then write in your notebook. Now we see the problem 12th. Problem number 12, cos raised to 7x, cos raised to 7x. Now write this as I, so I is equal to integration of cos raised to 7x dx. Now here power is odd. Now here when the power is odd, split it as in even power, taking one power from each, from this term as a separate. So we write this as cos to the power this 7 as a 6 plus 1, that is 6x, and cos raised to 1x dx. Here there is no need to write here 1. So we write 7 as 6 plus 1. So cos raised to 6x into cos x dx. Now this is equal to integration of, here we take 6 power, or we write this 6 as cos square x to the power 3. This 6 as 2 to the power 3. 2 3s are 6 into cos x dx. And now here we write the value of cos square x using the first fundamental identity. What is the first fundamental identity? Sin square x plus cos square x is equal to 1. Sin square x plus cos square x is equal to 1. From this fundamental identity, write cos square x as 1 minus sin square x. So here it is equal to integration of 1 minus sin square x to the power 3 into cos x dx. And now see here, if we put here sin x as a t, we get here cos x. And therefore use here a substitution method. So put here, put sin x is equal to t, differentiate with respect to x, derivative of sin x is cos x, derivative of t is dt upon dx. So cos x dx is equal to dt. So I is equal to, required integral I is equal to integration of 1 minus sin x as a t and it's a square, so t square and to the power 3 and cos x dx as dt. Now take the cube of this bracket using the formula a minus b to the power 3. What is the formula? A minus b bracket cube, a minus b bracket cube. It is equal to a cube plus, this is plus then sign minus, a cube minus 3a square b plus 3ab square and minus b to the power 3, b cube. So a minus b bracket cube is equal to a cube minus 3a square b plus 3ab square minus b cube. When here minus sign, then take here plus minus, interchange the sign, alternate sign here. Now using that formula, it is equal to integration of a cube means first term cube, 1 cube is 1 minus 3a square t minus 3 into a into t square minus 3a square b. So minus 3 into 1 square is 1 and t square as it is. Then plus 3, a is 1 and b square, t square to the square, t to the power 4 and minus b cube, b is here t square and its cube, so t square to the power 3, that is t to the power 6 and dt like this. We expand this bracket, a minus b bracket cube, a cube, 1 cube that is 1 minus 3 into a square means 1 square that is 1 into t square plus 3ab square, a is 1 and b square means t square to the square, that is t to the power 4 minus b cube, its cube, so t square to the power 3, that is 2 3s are 6. And now here take separate integration of 1 dt minus integration of these 3 constant, write down the outside the integral 3 integration of t square dt plus here 3 constant outside the integration of t to the power 4 dt minus integration of t to the power 6 dt. Now here, so integration of 1 dt is t. 1 is the derivative of t, so integration of 1 dt is t minus 3. Now here use this formula, integration of x to the power n dx minus 3 t to the power 2 plus 1 3 upon 3, then plus 3 t to the power 4 plus 1 5 upon 5 minus t to the power 6 plus 1 7 upon 7 plus constant of integration, and lastly put the value of t. What is t here? T is sin x, and therefore required integral I becomes I is equal to t means sin x minus this 3 and 3 get cancelled, t to the power 3 that is sin cube x plus this constant 3 upon 5 and t to the power 5 that is sin to the power 5x, then minus this 1 upon 7 constant 1 upon 7 and t is sin raised to 7x, and lastly plus constant of integration. This is the final solution or the 12th problem. Get it? Now see here 13th problem. Take here a screenshot. Now we will see 13th problem. Here tan 3x tan 2x tan x, tan 3x tan 2x tan x. Now here I is equal to integration of tan of 3x into tan of 2x into tan x dx. Now observe here the angle of tangent ratio. Here angle is 3x, here 2x and x. Now here 3x is the addition of these two angles. Such type of problems we create many problems here. If we take here 11x, here 5x and 6x, 11x is equal to 5x plus 6x. Now here we have 3x is equal to 2x plus x, 2x plus x. And now take the tangent ratio on both sides. So we get here tan of 3x is equal to tan of 2x plus x. And now here on the right hand side use the formula tan of a plus b, that is tan of 2x plus tan x divided by 1 minus tan of 2x into tan x. This is the formula of tan A plus B. What is the formula for tan A plus B? Tan of A plus B, we know, we have seen in the 11th standard, tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. This is the formula, and using this formula we write here tan x plus 2x like this. Now here carry this denominator to the left side, and therefore we get tan of 3x into 1 minus tan 2x 1 minus tan 2x into tan x is equal to tan of 2x plus tan x. Now here multiply by tan of 3x inside the bracket. Tan of 3x into 1, that is tan of 3x minus this tan of 3x into this tan 2x into this tan x is equal to right hand side is tan of 2x plus tan x. Now carry this term to the right hand side and all these terms to the left side. Here tan 2x. And so we get tan of 3x, carry this tan of 2x, so minus tan of 2x, again carry this tan x, so minus tan x, and is equal to carry this on the right hand side, so we get tan of 3x into tan of 2x into tan x. And now we solve here required integral. We replace this tan 3x into tan 2x into tan x by the right hand side. So required integral I is equal to integration of we replace this tan 3x, tan 2x, tan x which is on the right hand side by left side, and it is tan of 3x minus tan 2x minus tan x dx. And now take the separate integration. So it is equal to integration of tan of 3x dx minus integration of tan of 2x dx minus integration of tan x dx. And we know that what is the integration of tan x? Integration of tan x is log of sec x. So here final solution is I is equal to integration of tan x, that is equal to log x sec of integration of tan x is log of sec x, so sec of 3x, but in place of x there is 3x, so take the derivative of this 3x and its derivative is 3, derivative of 3x is 3, and so divide by 3, so here divided by 3. Now here minus integration of tan of 2x is log of sec of 2x and divided by derivative of this 2x as 2 minus here log of sec x plus constant of integration. This is the final solution for this 13th problem. So take the screenshot and write down. Here today's lecture we stop here. Remaining problems we will see in the next video lecture. Thank you.